Hey, what's up? So glad you could join. Thank you for being here. We've got an exciting one today. Get yourself ready. Grab a notebook, a pencil, or a pen. Anything you choose to write with is fine. This is math from the void. Math coming at you out of nowhere. Today we have a problem from the 2001 AP Calculus BC exam. That being said, if you were to use a calculator on this problem and you were in AB, you could solve this. Otherwise, if it's meant to be done by hand, this is going to require a BC technique called integration by parts. So give yourself about 12 to maybe 12 minutes. If you're using a calculator, just give yourself 12 minutes for this problem. If you're doing it by hand, give yourself 15. You'll probably need it. And then when you're ready, you can join back and see what we do. All right, great. Let's get started. So I see this chart. W of t in degrees Celsius, so that's the temperature, over time in days, okay? Always good to see the units of what they're talking about. I mean, that just helps give context to the problem. Now I know they're talking about the temperature of something, and they're checking it every few days. Pretty simple. The water in a pond, that's what the W stands for, I guess. The water in a pond has a temperature recorded every 3 days over a 15-day period. All right, let's just get started. Part A, use data from the table to find an approximation for W prime of 12. Now, since we don't have a function, we can't take a derivative. We don't have an equation to take a derivative of, but we can approximate the slope, because when we have a chart of values, the best we can do is use like an average slope. So for 12, I won't want to just say it's 22 over what. I'll probably want to pick this interval that sort of surrounds 12, so from 9 to 15, and see what's going on there. So we can say that W prime of 12 is approximately W15 minus W9 over 15 minus 9. That's perfectly good approximation there. So this is going to give us 21 minus 24 over 6. Negative 3 over 6. That's negative 1/2. And you should use the correct units here. This is going to be in degrees Celsius per day, because it's a change in temperature degrees per day over days. So it just means that on average we can say that at 12 days in, the water temperature is slowly decreasing by 0.5 degree a day. And again, this is not representing the exact change. It's just an average. It's possible that it fluctuates throughout the day, right? But we're looking at it across whole days. Oh, and it does say indicate units of measure. Yeah, very important. Don't forget units. It's like the dumbest reason to miss points. Seriously is. I mean, other than missing like 2 times 3 or something, but it's a pretty dumb reason to miss points. So part B, approximate the average temperature in degrees of the water over the time interval by using trapezoid approximations with subintervals of 3 days. So it doesn't tell you how many trapezoids you're going to need, but since each one goes 3 days, we're going to need all of these points. Luckily, these are equal subintervals. So what I can do, since the area formula for a trapezoid is 1/2 base 1 plus base 2 over 2 times h, they all have the same h of 3. So we can say that and let's also write the average temperature formula, or the average value formula, 1 over b minus a, and then we're going to have integral from a to b, in this case of w of t dt. Yeah, that's going to give us the average value. And we're going from 0 to 15, and we have to approximate the integral from 0 to 15 using these trapezoids. So we're going to say this is approximately 1 over 15 times, let's factor out the h over 2, 3 over 2, and then you guys might know this little trick. If they're all equal subintervals, we can take one of the endpoints, but we can take 2 of each of these middle values, and that's because each trapezoid is going to contain two sides. And so the first and last trapezoid will have the ends, but they'll include these middle ones, and then so will the next trapezoid, right? So we basically have, what is this, 20 plus 2 times 31 plus, let's see all those values, 28, 24, 22, 21. Got it. 28, 24, 22. There are two of those, and then the end point is 21, so there's only one of those on the final trapezoid. Okay, let's make sure I got that right. Double check it. Yeah, okay. Sorry for all the scrolling. Yeah, let's add these up together. So we have 62, 56, 48. I mean, this stuff is really not calculator worthy. If anything, this is kind of like jogging. Like if you're running up a course, this is like the flat part. Let's go ahead and move that half in there. Is that going to ruin everything? Nah, I think the half's going to make things a little bit nicer, to be honest. The only one that's going to mess with is this odd number. But other than that, let's put the half in there. So we have 10, 31, 20. I guess I didn't have to multiply all those if I was going to do that, huh? Plus 22 plus 10.5. Okay, so we have 69, I believe that is. Yeah. And then we have 66.5. Add those together, we get 135.5. This is times 3 over 15. I don't know why I'm tempted to divide these by 5 here. Maybe because there's a 3 there, so if I can divide these by 5, that'll work out really nicely with the 3's. What does this leave me with? This leaves me with 27.1. Yeah, so that's going to be in degrees Celsius. That is the average temperature. We used the correct units, even though it didn't specifically request. Oh, it says in degrees Celsius. Yeah, so it already gives us the units. Yeah, that seems pretty accurate, right? 27, right around the 31 brings the average up quite a bit, and then 20 also brings the average up quite a bit. So 27.1, I can believe that. If it's wrong, if I did it wrong, it's wrong. Then I don't get the points. Shame on me. Hey, it happens, man. I mean, if you know what you're doing, it's fine. Like missing little points here and there, it's not the end of the world. You shouldn't miss them. You should be accurate, but mistakes happen. If you know what you're doing, you're going to get the majority of the points. Part C. A student proposes this function, brilliant students come up with a function like this, as a model for the temperature of the water. Find P prime of 12. Okay, I do think this is intended to be done with the calculator, we'll see. Using appropriate units, so it says find P prime of 12. Using appropriate units, explain the meaning of your answer. Okay, well, I can explain the meaning of the answer like right now. P prime of 12 would simply, if P truly does represent the temperature of the water, then P prime represents the change in temperature of the water. It's a change in P, which apparently stands for the temperature of the water. So P prime is the change in temperature of the water. I guess the rate of change, like how fast it's changing. It's not just the overall change, the rate of change in temperature of water per day, because T is measured in days. So in degrees Celsius per day on the 12th day. That's important because that's what the 12 stands for in the P prime of 12. So on the 12th day. Now, as far as finding it, I think it wants us we have to take a derivative here. So there's no way that they just have you plug this straight into a calculator. I mean, I hope not. Okay. I don't know. I guess if they can. P prime of T, that's going to be, well, goes to 0, but this is going to be a little product rule here. So let's just do that carefully. We're going to have 10 e to the negative t over 3 plus 10t times negative 1/3 times e to the negative t over 3. So if I factor out 10 e to the negative t over 3, I end up with 1 minus 1/3 t. Interesting. Okay, so let's plug in p prime of, let's plug in 12. P prime of 12 is going to be 10 e to the negative 4, because 12 over 3, and then parentheses 1 minus 1/3 of 12, which is 4. So we get negative 30 e to the negative 4, which is negative 30 over e to the 4th. Okay, well, let's see what's going on there. So e is approximately 2.718. We're going to square that really quickly. Yeah, maybe this would be a calculator problem. 6 and 16 is 22. 2 and 112 is 114, 115. So we have 11. 43 and 14 is 57. 5 and 9, okay. And then 49, that's 58. 5. 33. And then we have 7. So 7.3875 is approximately e squared. Now let's keep going. Let's do 5 of these now. Let's get bold. Let's do it. Why not? We're here. Bust out your arithmetic. Show your skills. Sharpen your skills, always. We have 25. That's 72. 787 and 49 is 136. And then 13, 43, and 112 is 155. So let's see, 15. So we have 70, 85, and 42 is 127, and 64 is 191. 19. So 117 and 48 is 161 again. Let's see, 1, 2, 3, 4, 5, 6. Okay. 56, 112, and 16 is 128, and 9 is 137. Whew. It's getting tougher. Let's see, 42 and 13 is 55. And then we have 54. 1, 2, 3, 4, 5, 6, 7, 8. So about 54.57. Let's see, do we have to divide that? Yeah, I guess we need to divide that, huh? 30 divided by this. This is getting insane. Let's just put like 3 decimals and call this 54.571. That's probably enough, right? Okay, so this is going to be definitely a 5. Oh, I guess I should just take those away, huh? There's our, where's our pen? There's our pen. This is going to be a 5, so that'll be 5, 5, 8, 2, 2, 7. Here we go, pretty nice. 5, 3, 1, 7, 2. And then if we add a 0, again, we get another, basically, can almost fit another 5 in there. So if I had to guess, I'd say approximately negative 0.55. And again, this is in degrees Celsius per day. All right, so some heavy arithmetic there. If you just want to use a calculator, I totally understand. That's fine. because we still have another part. We have part D. But this really does build your endurance for the exam. If you can crank out calculations like this on the exam, you know, when you have the calculator, it's just going to feel like butter. Like it's going to feel like you're cutting through butter. It's so easy. It's like warm butter, room temperature butter. Use the function p defined to find the average value in degrees Celsius over the time interval. Okay, so now they again want us to use this average value formula, but they want us to integrate a function. And again, it's going to be a p of t now. So this is going to be 1/15 of the integral from 0 to 15 of 20 plus 10 t e to the negative t over 3 dt. And yeah, like I said, you can plug this into a calculator if you're already doing that, but this is an integration by parts problem. So this would be 20t. I believe it would be something like, let's see, minus 30 t e to the negative t over 3. And then since my dv, yeah, my v is going to be negative 3 e to the negative t over 3, okay. And then my du is 10, right? So that's going to be minus the integral of negative 30 e to the negative t over 3. So I guess those become positive, but then when I integrate it, it's going to become a negative again. So this will be minus 90 e to the negative t over 3. And this is all going to be evaluated from 0 to 15. Now, I kind of skipped some steps when I was doing the integration by parts there, just in the interest of time. But, you know, be careful if you're actually writing this out by hand. So plugging in 0 is kind of nice, isn't it? Because when you plug in 0, you just get 0. This turns into negative 30 times 0, so it's 0. This turns into negative 90. That's really the only interesting one that we get there. So we're going to have minus 90 somewhere in there. But let's plug in 15. So 15 times 20, we get 300 minus, oh boy, 30 times 15 is 450 e to the negative 15 over 3. So e to the negative 5 minus 90 e to the negative 5. Goodness, so what is e to the 5th? Maybe we can figure that out by taking this 54.57 and multiplying it by 2.718. Let's see what we get here. We got 56, 45 and 7 is 52. Then we have 37 and 49, which is going to be 86, plus 5 is 91. 49 and 14 is 63, 67, 102. That's how old your grandmother is. Then we have 15, 25, and 28. That's going to make 53. Then we have 48. And then lastly, we have 14. So let's see, 5 decimal places. 3, 4, 5. Wait. 1, 2. Okay, there we go. 148.32. That is approximately e to the 5th. So we're going to have 450 over 148.32. And we're also going to have 90 over that. But 90 over that is just whatever I get divided by 5. So that's, you know, pretty easy to do. So let's figure out what this is. 450 divided by 148.3. Okay, we can do this, what, 3 times? You know, I guess we can move our decimals. We don't really need any decimals there anymore. Yeah, we can do this 3 times. That's going to be 4, 3, whoa, what did I do there? 9, 4, and 2, 4. Yeah, looks good. Okay, so this is simply 51 away. Add a 0, add a decimal. That doesn't really go in. So add a 0, add a decimal, that goes in 3 times, which is the same 4, 4, 4, 9. So that's going to give us 51 plus 600, so 651. And then another 0 on there. That gets it about, not quite 6 times. So 3.035 I think is fine. And then if we want to take 90 over 148.3, just divide this by 5. You get the same thing. It's curious that it's divided by 5 rather than... Oh, because I multiplied 30 times 15. Got it. So let's see. That would just be 0.607. All right, so we can try to plug those in. We have 300 minus 1... Oops. Interesting. 300 minus 3.035, such a small number to subtract, minus 0.607, another small number to subtract, minus 90, and again, that's still times 1 over 15. So here we go. Subtract 90 first, that leaves you with 210. Then subtract 3, that leaves you with 207, 207.965, 207.358. And this is times 1 over 15. So let's bust out our division pants once more. 358 divided by 15. It's going to give us a 1, 15, 57, 3. Yeah, not quite 4. That's 45, which leaves us with 12. Here comes the decimal. 0.3. That's going to be about 7, 8. Yep. There's our 120. 35, that's going to give us 2. And then 30, that's going to give us 58, which again, not quite 4. So about that, which I have a bad feeling is like not really close to the actual temperature. That seems pretty far off, guys, doesn't it? I mean, you tell me. 13.823. I'm sure you guys using your calculators right now are laughing. This is probably hysterical. Make sure I did all this right. Minus v du, which was going to become a negative. I mean, even if some of these things became positives, it wouldn't be that large of a value. Minus 90, yeah, that seems okay. Checking through my work, I can't particularly spot the thing. I will tell you this much. I will save you some of the headache. Getting to this point is going to give you pretty much all of the credit. The rest of this calculation that I'm doing, this is worth like 1 point. So it's really, I'm not saying you shouldn't do the calculations, and clearly I did something wrong. So I'm not shying away from that. But I do want to emphasize that knowing what you're doing along the process of the problem is really what's going to get you most of the credit and most of the points. Okay, so curious what the actual average value would be if you did this on an integral calculator. And I want to try to attempt this one more time since we're already here. I know we wasted a bit of time, but let's take a look at what could have went wrong. So we had uv, which is 10t times negative 3 e to the negative t3, minus the integral of v du, which turned that to a positive integral, but then when I took the integral, it turns into negative 90. Yeah, I'm genuinely unsure on what could have went wrong there. But I will say that average value is completely off because it's not even attained once from this. It should be somewhere around the 20s. Yeah, a lot closer to the 20s is where it should be. Oh, do I see the issue? Is it minus a negative 90? Oh, guys, this might change everything. In that case, it would be, let's erase some more of this. Let's erase this stuff. Yeah, I think it's minus a negative 90. That could be my issue there. So all the hooligans that were laughing at me. Maybe I'm on the right track now. So this would be, let's see, 3. I guess I could have just added 180 to that. This is going to be 390 minus 3 is 387. 386.65. Sorry, 386.965. 386.358. This is looking way more promising, everybody. I guess I could just add. Yeah, I could just add. Okay, so since 90 over 15 is 6, I could just add 12 to what I got, and we should get around 25, which is going to be nice. So here we go, 2, that's promising. 8 and a 6, that's going to be, oopsie, not 6. It's going to be 5. And I wrote a 6. That's going to be 5, like I said. And this is 75, 11, 3. There we get the point. There's our 7. Yeah, so this is looking way better as an accurate. This student, whatever student proposed this model, is doing a pretty dang good job. That was a pretty clever model to propose. 75, this is going to be 10, 108 gives us 7. So approximately 25.75 degrees Celsius, that is the average temperature. Now I stand by my answer. And I'll cut all the blab short. I think you guys get the moral of the story. Doesn't hurt to work things out by hand. If you're in BC, I really don't expect you to have worked that out by hand. Actually, it would probably take you too long. No offense, but you would most likely use a calculator here. Yeah, anything else to mention? Nope. I'm done blabbing, guys. See you next time.